All right, here's the 2026 AB Calculus number 4. First time I'm really looking at it much, but these are usually pretty predictable. When you're given the graph of f prime, that's usually what they give you, and you're just kind of using that. Just always make sure you know what you're looking at. You're looking at f prime dot f. Part A says for x greater than 0, the function g is defined as g of x equals f of x minus natural log. Find g prime of 2. Okay, so that's pretty easy. Just if you get confused at all, getting sort of narrow, sort of tunnel vision, focus on, okay, where is G? I've got to find the derivative. Well, G is right there. So find its derivative. We will worry about G prime of 2 in a minute. Let's get G prime of x first. Well, the derivative of f of x is f prime of x, and the derivative of the natural log of x is 1 over x. Now that you should know if you're taking AB calculus. G prime of 2 is therefore f prime of 2 minus 1 over 2. And f prime of 2, remember, know what you're looking at. You're looking at f prime. So f prime of 2 is right there. It's 1.5. So G prime of 2 is 1.5 minus basically 0.5, or that's just going to be 1. So I'm liking G prime of 2 to be 1 for part A. Part B, find all values in which the graph has a point of inflection. Now, so much of calculus, if you're watching this and you've yet to take the AP exam, so much of it is just sort of a trigger that you're looking at that you have to fall back on your knowledge. So in part B, the point of inflection is when your second derivative changes sign, okay? The second derivative changes sign. So we're looking for the graph of f. Realize that this is not f, this is f prime. So it's talking about a graph that I am not looking at. So I need to figure out, when does f double prime transition one way or the other, okay? Well, how can I get f double prime from f prime? Well, one thing that we should know that sometimes gets lost in the shuffle is that f prime, double prime is positive. That is the same thing as f prime increasing. Okay. So often we just think of f double prime and positive being f concave up, which is true, but there's a relationship also between the second and first derivative. Similarly, it's decreasing. Okay. So when I transition from positive to negative for f double prime, that means f prime transitions from increasing to decreasing or vice versa. So I'm looking at f prime, it transitions from decreasing, right there. At this point, it begins to increase. So this is one point of inflection right here. Not of the graph we're looking at, but of the graph of f, that's what's asking. Let's see, make sure we got this. At which the graph, okay, now we have to be careful. It does say from 0 less than x less than 3, so that we're actually not going to count that. But we're increasing. We hit here and then begin decreasing. So again, for f, the graph that I'm not looking at, that is a point of inflection. 1, 3 is a point of inflection. Okay. And then at 3, I do it again, but it says specifically x is less than 3. So I need to give a reason, always give a reason or when it says. So at this point, we say f prime transitions. You don't have to say transitions, but that's a good word here to use. From decreasing, you might want to write that out, decreasing. I don't have an eraser on this thing. So increasing. So f double prime transitions from, let's say, decreasing negative to positive. Okay, which is what that is. That's what point of inflection is. Remember, the reader of this test, they have to, you can't just, you got to let them know that you know what you're talking about. Okay. If you say 1, 3, who's to say that you just didn't luckily guess 1, 3? Part C down here says, so you might want to get this. I'm going to get rid of this part. For -4, let's go up just a little bit here. For -4 to 4, what open intervals, both increasing and concave up? Okay, again, this falls back on your just knowledge base. It's the graph of f, a graph that I cannot see. So f increasing, so let's write some stuff down. F increasing, that means f prime is positive. All right, that's just calculus 101. Concave down, if f is concave down, that means f double prime is negative, okay, right? Which in turn means f prime is decreasing. That connection from f prime to f double prime is an important one to make. So I'm on the graph that I can actually see, which is f prime, I need to know at what points is it both positive and at the same time decreasing. Well, that would be from here to here. I'm above the x-axis, but I'm moving down to the right. So on what open interval? That would be from open interval from 1 to 3. Again, I understand this, it may not necessarily, it's that graph I'm looking at is decreasing and concave up there, but it's a graph that we cannot see, the graph of f. All right, part D. Part D says this, find the value or absolute. Anytime you see this absolute, this is the candidate's test, some people call it, or you'll test your endpoints and test the critical points. All right, and see what's what, right? So the endpoints, of course, would be -4 and 4. That's your endpoints. Your critical points would be when your first derivative is 0 or undefined. My first derivative is 0 here at -2 and again at 3. Okay, so that's what I need to test here. Now, let me actually clear this. There's a beginning of this that we may need to see. All right, I'm gonna go up and clear this so I can see the top of it. Yeah, right there. So we need this information. F of 2 is equal to 3. So that's important to know. So let's go back down to D here. So F, get my mark back. So we know for part D that F of 2 is equal to 3. And I need to know when I have an absolute minimum. So we need to calculate or think about what is f of -4. That's one endpoint. F of -2, that is a critical point. F of 3 is a critical point, and F of 4 would be the other endpoint. Right? So again, I know F of 2 is equal to 3. So F of -4, that would equal that 3 that I currently have. And because there's just also calculus 101 here, the antiderivative of a rate is equal to an accumulation. So you want to know that. And of course, here we're doing the antiderivative of f prime. And that would be what accumulates under the graph for for the collection for f. Okay. So if I'm f of 2 is equal to 3, think about what happens at this moment. What is happening? Well, I'm going to accumulate. I don't actually have a number here because we don't have f, but we can think about it. This is going to add a bunch. I'm going to add. This is going to be way higher than 3. So at f of, sorry, I started this f of -4, but at f of 4, we'll go to this one. It would be 3 plus what accumulated between 2 and 4 for f prime. Okay? And that's going to be a very large number, 3 plus, I'll call it, because of that accumulation there. Meanwhile, f of 3, well, f of 3 would be 3 plus the accumulation from 2 to 3 of f prime, which again is going to be 3 plus, but it will be smaller than this because as you go to 4, you're going to accumulate more. So that's because it's looking for a minimum, that's going to eliminate that one. What about f of negative 2? Well, the f of negative 2 is the same thing as accumulating from 2 to negative 2 of f prime. Well, that in turn, they come down here, would be like saying 3 minus, because I got to fix those limits. Remember the limits on the integral there? If they're upside down, or if this bigger one's on the bottom, you'll flip it. So that's going to become a minus. So what I'm doing essentially is I'm backing this up. Let me change colors. So from this red line here, this orange area, all of that's going to get subtracted from 3, right? So this is going to be a 3 minus right here. It's 3 minus. I can't actually calculate it, but I can see here that it's going to be significantly less than 3 because I subtracted that area. I'm backing it up, so to speak. Now, as I go to 4 right here, get the colors back. On 4, I started to say it here. The 4 will be 3 plus, again, accumulating from 2 to negative 4. Well, that would be 3 minus, and I got to fix this. But what happens here? Well, here you begin to accumulate this area. Okay. So you're backing it up, remember? Well, if I subtract the orange, let's just say for the sake of argument, this is 2. This is just to illustrate this. And this is 5. And let's say that. If that were the case, and again, I'm just making up numbers so we can see this, we would have f of negative 2 would be 3 minus 5, which is negative 2. But f of negative 4 would be 3 minus 3, wouldn't it? Because you would subtract this positive 5 here, but also you would subtract the negative 2. So that would add the 2 back. That would actually be 0. For that reason, the absolute minimum should occur at negative 2. And a reason for your answer you could write out is that basically just to show the work here would be fine, to show that you are, so let me just write it out, at negative 2, or let me just say this, f of negative 2 is equal to 3 minus going from negative 2 to 2 of f prime of x dx officially. Okay, and there you would say it's 3 minus a positive number. Whereas if you found f of negative 4, you'd have 3 minus this, which would be 3 minus a positive number, but then plus, so that would make f of negative 4 actually larger than f of negative 2. Okay, so that part D is a little bit confusing, but I feel pretty good about that. I don't know that that's the most elegant explanation, but I think showing that work should be hopefully sufficient for that.